this video, we are going to briefly discuss how we can use GIS to help us to make a better decision regarding the evacuation plan for a specific volcano event. So this is usually known as a multi-criteria decision-making process that GIS helps to basically make better and more effective decisions. But let's just first start by looking at the disaster management phases. Let's just start by looking into the disaster management cycle. There are four phases for disaster management. Two phases happen before the disaster, and two phases happen after or during the disaster. So the first phase is known as mitigation, or to prevent future emergencies and take steps to minimize their effects. So that is usually done regularly to make sure that if an event actually going to happen, how the future impact could be minimized. And of course, unforeseen impacts are going to be changed in the event of more information that usually is going to be brought in by the newer technology or science. The phase two, known as preparedness. So usually making sure the actions are taken ahead of time to be ready for a disaster, for an emergency. For example, let's say just saving water for the event of a disaster, saving some foods that not perishable. The third phase usually happens right at the beginning or right maybe a little bit before the disaster actually happens, is known as response. So that's how to protect people and property in the wake of an emergency, disaster, or crisis. Some events such as, for example, earthquake, maybe they don't have a time ahead to be kind of making those responses. There are some events such as maybe a specific type of volcano, or there is a flood warning, or there's some other types of disasters that, because they usually start somewhere else, they provide some time to start the response stage. The last phase, or the phase four, is usually happening after the event, maybe toward the end of the event, recovery, to rebuild after disaster in effort to return the operations back to normal. So these are the four phases of disaster. In the current video, we are going to discuss the response for a specific case known as volcanoes. So if a volcano happens in a specific location, usually we know some of the regular places for volcano events, how we can possible action provide, how we can make those possible actions. So think about the volcano evacuation. First thing we wanted to do, focusing on specific areas that are more inclined to have volcanoes, is to explore data and ask questions about different things. Let's say if a volcano happens, how much time do residents have to evacuate? That is going to be based on so many factors. For example, population play a huge role. The road access, road capacity, the mode of transportation, the geography, all of these would be an important factor set that we need to be worried about. Just a fact is that lava flows downhill, right? So the slope of gravity helps to do that. And usually volcano happens in higher elevations, and then that is going to be usually flow to the downhill locations. So we have to take into account the slope or the direction of the slope, known as aspect. So that can be easily calculated in GIS. If you know the elevation model, or what we call digital elevation model, or DEM, we can easily calculate the slope, and then based on the slope aspects is the direction of the slope. Is it going to be toward the north, toward the east, toward the south, and so on. Also looking at historical maps and events, would help to significantly learn from the past event, learn from the actual events of the volcano. Then the task starts by looking into the or identifying the lava flow hazard area, creating a map of hazardous area, focusing on topography and geology, and then also bringing the slope would help us to really make those hazardous area much more accurate. It's like a flood area. You look at the past event, look at the soil type. Same thing for volcanoes. You have to consider the geology and the topography. Then the next thing would be looking into that hazardous area. You want to stay away as much as possible so we can create evacuation path and shelters. The picture you can see is great example of knowing where the shelters are, where the evacuations routes. So we can possibly uh, add these into our locations or into our cities that are more inclined to regular volcanoes. Then we can look at the distance accessibility, looking into the road network. We create drive time analysis. How long does it take from one location to drive to another location? Let's say 15 minutes drive time. Is that enough to reach from a specific high risk area to the safe area for the people who are living into the highest risk area? If not, what we can do, right? So these are the questions that we can create scenarios for and find out the possible uh, areas that we may need to provide more services because it takes more time to evacuate those. For example, if the road access is not good enough, if the road is not able to provide good access for the residents, if the topography is not really easy access, so all of those could be really calculated and use the GIS maps. We can really calculate those. Then looking at the population capacity, population, of course, easily to take into consideration for different areas, but then also we need to consider capacity of the road network, consider capacity of the teams that are going to be providing the response. Are they able to help? Are they able to notify the residents right on time? And then there could be a plan for necessary item. This is possible item for the preparedness, not really for the response. However, if the event is more likely to happen, we may revise the supplies. And that's another thing to consider. These are not going to be uh, static items. They could be a change of plans, or we may think, okay, so that's a medical supply is good for 2 years. After 2 years, we have to, uh, because it's going to be expired, we have to replenish that item. Then we have to think about the mobile hospitals, because of course there's going to be hospitals around, but are they going to be in the most hazardous area? And if the event actually happens, we may rethink those hazardous areas. We think, okay, now we have a higher risk type of volcano with a lot of lava activity, or maybe we have a lot of winds that is going to be transporting all of the ashes to that specific hospital. So we have to think about, okay, how I can create another hospital, mobile hospital in another area. Uh, the next item is to identify data center disaster monitoring areas. So think about the teams that are going to monitoring areas, making these decisions right on time, real-time basis, and making sure everything is right in place. We have to find a location for them, and maybe that is not known before the actual volcano, but we need to think about different scenarios right here as well. So we can categorize different levels of volcano activities, and based on that, we can think about ways we can create those data centers. And remember, we need for the data centers, we need electricity, we need communication network, we need uh, all sorts of hardware and software. So that's going to even be much more difficult to uh, accomplish in a shorter time compared to some necessary items, because we can't just create those data centers without you really using it. So we may think about reusing some of the existing networks if the actual event happens. For example, the city or other organizations, they can maybe accommodate some of the needs right at the moment of disaster. And of course, the communication modes to the residents. That's another thing to think about, how we can communicate with them. Maybe the internet would be great, so we can communicate them with the uh, guess of them having access to internet and knowing that they have to look out for the evacuation notices, but maybe that's not the case. So they have to think about other ways of communication. Radio flyers. Flyers could be used for some of the information about the shelters or the evacuation path, not necessarily for some of the actions, because they might be more time sensitive. But all of these communication modes should be also thought of. And this is an example of a Hawaii evacuation shelter analysis. You can look at the map. The link is provided underneath, but you can see that this severity code based on different types of lava flow hazard area. These are color coded, and then we have the population of different areas. We know, okay, that's darker color represents more population, and that's a high hazard area. So if you want to really act based on that, this is going to be the case, and you need to pay more attention. And we can bring in the volcano location. So this is going to be the volcano location. This is right next to that highway or next to that road network. So all of these would be really important to consider, and then the closeness of that high population area to the hazardous area and the center of that volcano would impact the direction of that evacuation. We don't want to bring these people closer to that area, so we want to probably move them away and put them into lower hazard area. So this is a very quick review of ways you can think about using GIS to help you create evacuation path and shelter analysis. And of course, looking at the topography and elevation, you can look at that from the 3D dimensions and 3D aspect of it. And this is really something that we can do, and we are doing already with the help of locational data. And please, if you get a time, take a look at this map, explore that, and thank you.